I'm going to kick this off by saying that we hear a lot about the cloud. The last two keynoters, it was cloud, cloud, cloud. It's all you heard, or it's most of what you heard. As well as, personally, many of us are using the cloud. I'm sure if I asked how many people here are not using the cloud for something, anyone here not using the cloud, whether it's iCloud or Dropbox or Box, for anything, they're not using the cloud for anything. So, okay, everyone here then is 100% adoption of something in the cloud. Our businesses are using the cloud. And we don't often talk about what makes the cloud tick and how the cloud can improve. But what we're going to discuss a little bit about today is the inside of the cloud, the guts, if you will, of the cloud, the things that actually make it work, and the interconnectivity, the connective tissue of the cloud is probably a better way of explaining it. And with that, Raza, I'm going to kick it off to you and ask you, how are you seeing the internals of the cloud changing, and what do you envision for the future?
Rich, first of all, thanks for the opportunity of being here, and thank you, everybody, for being here to listen to us. When we look at a cloud, really, it's a combination of a lot of data centers that make up the cloud, and within the data centers, it's really, at the end of the day, servers and storage devices interconnected that allow us communication and give us what the cloud is. And I'd really like to talk a little bit about innovation in the components, as well as really how we can transform these networks for future. And what I mean by transform is, let me take an example. Our requirements for bandwidth are not decreasing anytime soon. We keep adding more applications, more bandwidth-hungry applications, and that really translates to more switches, more routers, more servers, more fiber optic and copper cable networks. The essence of it is the size of our networks, look at the data center, or any network for that matter, grow, and they will continue to grow. And as they grow, we have, certainly we consume more power, dissipate more heat, consume more space, and all those wonderful things. Can we really say, if our bandwidth needs will continue growing, is it sustainable that the power consumption can just continue growing as we move on? And we think we have to fundamentally look at networks differently. And that's what I'd really like to talk about, innovation from servers to storage to switches, and how our networks will change as we move forward.
So there is a common trend in these data centers which really make up the cloud, and that is that we are seeing the number of cores within a data center growing at is it safe to say, an exponential rate? A virtually exponential rate?
It is, and if you look at every component of it, right? Let's look at servers. Processors get stronger and better, and we need more virtual machines and more containers and more servers get stronger. Switches get, innovation within switches continues. We've gone from 1 gig to 10 gig to 40 gig to 100 gig ports, and more ports in a 1 RU space. So speeds and feeds continue increasing. Storage does the same thing. So yes, our networks are continuing to grow from the perspective of, based on our needs, of course.
So as you have more cores, then the communications within a data center or within the cloud becomes more challenged, because the more cores you have, the more stress you put on switches and routers and things like that.
Size of the network, right? For example, let me look at why we need these big switch cores or switch networks. Many hops in them as well. Yesterday, a few years back, the number of servers or number of compute you had in, let's say, 10 or 12 racks, you can have that much now within one rack. As we move forward, more processor innovation and servers and more cores, you'll have that much compute power in 2 or 4 RU servers. So we're putting a lot more in our devices in the innovation. Which forces us, there's more bandwidth, there's more packets, forces us to have more faster and bigger switches. And what ends up happening really here is, in our networks, in data center networks, we have multi-tiers of switch aggregation. Whether you had a three-tier architecture where you had a top of rack, end of row, and some core, or you have a top of rack and a spine architecture. Any way we look at it, the number of elements in our network continue to increase. And that's the part that, how do we change that? Or are we really in a very proportional increase of equipment, power, heat, and so on? And, if we look at it, data centers, Rich, you talked about switch and switch cores. There's a few vendors that really own the switch market. There's a lot of vendors in there, but frankly, openly, Cisco dominates the data center infrastructure, right? And in that world, there is innovation. Certainly, when we talk about just like processors for servers or speeds and feed for switches, I'd like to call it, at best, it's still it's evolution. It's incremental innovation. And, incremental does only so much. When we look at the last few years, you saw some white box switch vendors appear in our market. They're using the same silicon, the same chip technology as the big guys. These are the people such as Quanta and Acton and Foxconn. In the beginning, our industry, probably me included, we all said, well, how are they going to compete against the large incumbent vendors? I'd call it more than just incremental innovation, but slowly the large hyperscale guys started using these switches, the Amazons and Googles and Facebooks and so on. Got a little more credibility. They're not widespread, but there's a lot of them coming in the picture. That really changes the game a little bit by having more of an open environment and switching technology from somebody other than those few vendors.
So as the technology has evolved and we've seen the number of interconnections grow, what is the solution to allowing the data centers to more effectively serve the needs of the clients?
So, Rich, a solution that can more effectively or basically transform network infrastructure. What we look at is a thing that I say, it's incumbency versus innovation. Certainly innovation can happen in a lot of places, and it happens at these massive companies. But a lot of times, really, innovation that changes the infrastructure comes from somebody other than the incumbents for obvious reasons. One of the things we look at is, for example, several companies, ours included, we're looking at an infrastructure that just has fewer switches in it. In other words, we say you're not going to need the large core switches in your network. Can you live without the very large core aggregation or spine switches in your network? Just switch at the edge. And the answer is yes. Imagine if you could remove the core switches from your network. How does that change your network operations? You don't have to be looking at $1 million service contract for those at the end of the year. You've got less power, less heat. It just simplifies your network. And there are architectures today where one we're looking at, an optical core, and really switching at the edge. And I can explain a little bit of how these technologies work, if you...
Yeah, please do. So
today, when packets come out of servers, a server has X number of interface ports at whatever speed. You send those packets to a switch, and at the first switch, when they hit the first switch, that's where you decide how you're going to move the packets. Well, in many data centers, the only place you go is where your aggregation switches are, but you'll make that decision at the switch. What we look at in these networks is to say, let's understand the traffic. Let's not blindly just aggregate traffic into a top-of-rack switch and aggregate to a spine or a end-of-row switch and aggregate on. Or, as I sometimes call it, punt the packets down to a bigger switch. You can look at these packets, understand your network overall, and perhaps steal the elephant flows and take them directly. There are technologies available today that you can create a direct path from one point to another and steal your elephant flows away. In other words, imagine packets going to storage. What do we do today? We just send them into the switch network and hope for the best. Why don't we know how much traffic is going there. Why don't we designate ports, move them across, and reduce the switching infrastructure in the middle of the network? And these technologies are working. And this is where, Rich, I say the innovation versus incumbency. I do not see an incumbent vendor walking in and saying, let's talk about fewer core switches. As a matter of fact, they're interested in larger and larger core switches. Before being in a startup, I was with one of these large switching companies as well. And the wonderful thing, particularly in data centers, is when you own the core, it's a sticky environment. You stay there for a very long time. So certainly incumbent switch vendors are not going to be talking about taking a core switch out. We look at it and say, we really do not need X number of layers of switches when we can do it more efficiently.
So let's see if I can sum this up. From what I hear you're telling us, then there was a huge change in the communications market some time back. In order to do telephony and eventually voice over IP, you needed a DSP resource board, which is an expensive product that it could run anywhere from 3, 5, 10, 15,000, depending on the capabilities that you needed. And in order to have a voicemail system or to have a voice over IP gateway, anything like that, you had to buy these boards. And so basically over time, the need for these boards decreased because of things like software HMP, where the media processing took place on the host, which took place on the Intel processor. And over time, we saw how software kind of ate the hardware in that case. And the Intel processor removed the need for maybe tens of millions, hundreds of millions, billions of dollars worth of equipment. And so what you're telling us now is that a similar kind of change is going to take place within our networks, within the cloud, whereby the processor is going to, with software and the proper algorithms, is going to make it allow or enable the processor within the servers to do more and more of the work that we used to have to spend a lot of money on switches to do. So basically the processor once again becomes more powerful and does more and more of the work.
That is exactly right.
Well, is there anything else besides the processor? In other words, what about the way the processors connect to the server or connect to each other? How does that work?
Absolutely, but before I go into that, I think the telephony example there's a lot of telephony savvy people here as well, is a great one. My past life, I ran Fujitsu's F9600 business, which was digital PBXs, and then 3Com's telephony business, IP telephony business. IP telephony is a great example for this, right? In our digital PBXs, what did we have? We had line cards and the call control. It was a big thing, and we always talked about lots of lines of code. When IP telephony came in, we separated everything. Call control was sitting in a server somewhere. What used to be line cards and PRIs and all that, we created a thing called a gateway and moved that across. Telephones that had very proprietary protocols connected into those PBXs shifted, and we had it running on IP technology. Absolutely. Exactly what IP telephony is a great example. How we look at these switches is, today we're in a world where we say servers take packets and send them to the switch that they're connected to. And then certainly there's routing protocols and all one switching methodologies, and you deliver that packet to the destination. What we look at is we see that where this technology is evolving to, you will see very high density fiber optic ports on servers. And if a server is sending traffic packets, instead of just bundling them down one interface and letting somebody else make the decision, you could make the decision right at the server and basically say, I'll take my elephant flows in these high-density fiber optic interfaces directly to destination X. But to do that, what you really need is a centralized orchestration system that understands the network and is actually able to deliver direct connectivity automatically controlled from software.
So to further the telephony analogy, that's kind of like least cost routing in that case, right? Because you're not invoking another piece of hardware and adding delay. In this case, you're just direct to direct, like peer-to-peer connection.
That's correct. One of the things we look at from our company, we create what we call the PLPs, or programmable light paths. So, and there's other things of this nature in the industry. From any point, any port in the network to any other port, we can dynamically create a fiber optic connection at 10, 40, 100 gig at any time without any human hands in the network. And when you can change the physical infrastructure dynamically and control the packet flow on top of that, it really has a very powerful control mechanism and an efficient way to build a network.
To use more analogies here, and tell me please if this is accurate, is that kind of like then bringing the concept of a mesh network to the data center where any of these devices can directly communicate with any other ones and they're meshed in that way, as opposed to having to go up to some set of switches and then come back down?
That is correct. When you say mesh, a full mesh in anything would be great, but getting to a full mesh is very expensive. In these technologies, you can have a mesh, a controllable mesh for all your high flows, and let your small to a switch network. So it is a controllable mesh technology that can give you direct connections across the networks. And when you look at SDN, software-defined networking added to it, it is truly leaving the data plane in your connection and switch world, and moving the control and management plane to a central entity, central orchestration system, so you can have a deeper understanding of the network.
Okay, so the basic concept here is that once you know what flows are going to be larger flows, assuming you have some sort of predictive ability to do that, you have the algorithms that basically make the data center much more efficient.
Correct.
However, in order to get there, the servers need to have some sort of fiber optic based interconnected bus, which gives them the flexibility to interconnect with other devices in the data center, whether they are other cores or storage or other things within the data center that they would need to connect to.
That is correct, except I'll say it this way. Servers will get there. Today, how these deployments will happen is the closest switch, a top-of-rack switch, will be the one that will have a lot of fiber optic connections and be able to flexibly and dynamically connect and give you that physical connectivity as well.
So currently we're going to go through the top-of-rack switch. However, over time, we're envisioning, so this is kind of like, for those of you who've been in the telecom industry for a long time, Dialogic that made these DSP resource boards that allowed things like IP telephony to happen was purchased by Intel because they kind of saw this future. And so what you're saying is we're kind of, and I think I was in the late 90s, 97, 98, and then within about 4 or 5 years, this transition took place where software became the driving force for IP telephony as opposed to proprietary hardware. And so we're kind of at that, looks like that window, that 3 to 5 year window where the server is going to become more and more of a, I guess, switch-like powerhouse.
Well, in a way, I say that, not 100%, but a major portion of switching, what we call switching in a network, can be consumed by the server. The server can make decisions. It knows what... Folks, at the end of the day, It's all about applications residing in hypervisors or whatever type of environment you have. Switches, routers, servers, cables, all of that is plumbing. I mean, we as vendors, we talk about our platforms, how efficient they are, but they're all plumbing. And at the end of the day, we need to be able to create the most efficient way to get packets from anywhere to anywhere. And for large flows, the efficient way is not going through 4, 5, 6, 8 hops. If you could create a direct path and control it, why would you not? And those, our networks and data centers are shifting to these flexible architectures rather than the very rigid things that there was a time I was in an incumbent switching company as well. We defined things in certain ways, but today that network is changing.
Now, I just wanted to let the audience know, too, if you have any questions, feel free to raise your hand. I want to make sure that you have input here in terms of the direction we're going in. But my next question is on Facebook. Facebook has been doing some innovative things in the data center as well. Does any of the things at Facebook...
So interestingly, Facebook, in a way, proved the point, one of the points we're making, that you don't need if I may say, a Cisco, Juniper, HP, and a plethora of vendors. You do not need those infrastructures. You can work, in their case, their Open Compute project is a great thing for everybody to look at. They used really white box switches to build a very massive architecture in their last data center in Iowa. And they actually proved the point that you really don't need those incumbent vendors. I will say one thing, though. In the case of those hyperscale data centers, they have a lot of resources to do this. And as time goes on over the next 12 to 18 months, you will see those sorts of orchestration, centralized orchestration systems that Facebook built or Google built or Amazon did, be available to every network. And those are the areas we're working on. And, from a Facebook perspective, that's a good thing. Some of the architectures, as you see, as you move forward, it will reduce even more switches from the network and make it more direct.
So, this is really a disruptive technology in terms of where things are going to be going within the data center and the cloud. Go ahead.
May I say one more thing? So certainly, if I was one of the incumbent switch vendors, I'd say, this is not going to work. Incumbent switch vendors said that. The white box wouldn't work. It's there. Incumbent switch vendors didn't want to join. Some did. Cisco wouldn't want to join OCP. They denied it. They did after 16 months of saying no, just a month ago.
Can you define
the world
OCP?
is changing.
Please define OCP.
It's the Open Compute network. It's Facebook's Open Compute network that shows how these architectures are built, and it's on it's on the web, open for anybody to see. So the biggest incumbents are joining that wave, which is an indication that we are headed to a different type of network infrastructure.
Now, it's interesting that the switch vendors that used to be standalone and not associated with any necessarily a server company, now the switch vendors and the server companies seem to be integrated. They're one and the same. So I'm wondering if they are less threatened by this than we might originally think, because they might be able to add something onto their servers and charge more for the server.
I think, Rich, over the next 1 or 2 years, you'll see a lot of change in that space. And I'm a proponent of the fact that the server and the processor at the server is very powerful, and it can make decisions. It is making decisions of where the traffic will end up. Given the control that could actually have control over the routing and what is more important, which packets are more important than other packets, it will. I think it'll affect the switching market tremendously.
Okay. That's fantastic. So, no questions? Oh, we do have one question here. Yes, sir.
Yeah. Question for Raza. On SDN, are you aware of any standards that are being developed by either IEEE or any other organizations
So let me just repeat the question. Are there any standards for SDN from the IEEE or any other associations?
This is evolving, and to be frank with you, I was just reading something even as late as yesterday. SDN means different things to people, right? And if you look at it, SDN really, we have our definitions, of course. We can talk about abstracted networks, and we'll simplify things. But SDN really, as we look at it, is being deployed. People are adding more, but still it's a very small market. And when you look at it, the reality of it is it's a very big challenge. I heard the term the other day, SDE, right? Software-defined everything. So you've got software-defined networks and software-defined storage and software-defined toasters, for all that matter, right? People are looking at small pieces of solving small problems in a network using a software-defined environment. I'm a big proponent of SDN. From my own company's perspective, we're looking at SDN to leverage changing the entire infrastructure. In other words, what we're saying is, if, unlike networks of today or yesterday, where you have a lot of switches and routers and things building the infrastructure, in that world, just look at switches. To me, a switch has local significance. Packets come in, it looks at its table and says, go out of that port or that port. A switch by itself does not understand the entire network. It never has. It builds a table by ARPing or a router through routing protocols, and its table sits there and it says, packet comes in, look it up, send it out. SDN allows you to have an overall network view. In other words, not thousands of independent minds making their own decisions, but in harmony, all of these devices, all these switches or routers or whatever it might be, working from a centralized control environment. And if that is true, a centralized environment will control that, then I'm pretty sure you can put a $10,000 device for that switch rather than the $110,000 device, because the smarts are up here, not down there. So SDN is different, but from a standards perspective, I think you will see some, as more deployments come on, some standards how should I say, vendors working together to build a consortium of features, functions, and so on.
Fantastic. So, Raza, we've got approximately 2 minutes left. And with the 2 minutes, I just wanted to give you the opportunity to just share with the audience anything else they should be looking at in terms of data center evolution, what's going to happen in the next few years from your perspective.
From our perspective, we think the incumbency of vendor or type of solutions is being challenged and will change, which will allow data center operators and customers to build more efficient networks, truly change the dynamic that says, as our networks grow, our needs will continue growing, how can we build a more scalable network with less hardware? We are going to have to look at it in that manner. And just one thing from our perspective, if some of the things we are proposing are available to, in our booth in 821, please come visit us. I'd love to talk to you.
Thank you, Raza. That was great.
Thank you very much.
Much appreciated.